This question's very involved. Okay.
How many volts is it worth?
This question, you betcha. This is a tough question.
Is it worth a lot?
Come on.
Yeah, it's worth some points. Don't worry, I'm going to, like I said, I'm moving it later on. I'm taking some of this away, and I'm putting in its place that derivation that we did at the very beginning. Okay? Unless you'd rather.
Not have this at all on the test.
Yeah.
You should switch this out for the derivation.
Yeah.
Like take this
Or
out.
you should just have this be the test.
Let's
This
do both.
one problem
Let's finish
covers
up.
mostly everything we've gone over.
This one problem covers a lot, doesn't it?
Yeah.
Yeah. It's a tough problem. Don't worry, it's not going to be. I'll have a couple of these things in there, but you're going to need to do the derivation. Focus your attention on that. Don't ignore this. You just have to really, really slow down, which is why I can't really put a lot of this on the test. In order to do it properly and effectively, you have to slow down. We don't have that much time. So I'll put 1 or 2 questions from this on there. Not this whole big, what would this be? 10, 20, 30, 40, 50 point question? No, that's not going to be there.
So it's not going to be A through E. It'll be like A or something.
It'll be probably more cast into the true, false, multiple choice. Or maybe 1 or 2 questions. Okay? But the derivation's going to take its place. Okay? I want you guys to know that derivation front to back. Okay? So, yeah, because I agree. The problem is, with this, you have to slow down so much in order to do it effectively in a test situation. Although I've had it on test and I've had people nail it. This is not something that's not been done before. We just haven't had enough time to cover this properly in the lecture. And so, okay, what's the next question? We're down to E. Oxygen will be produced at the anode with electrolysis of solutions of which ions? Okay, well, oxygen is produced from what? It's an oxidation. So which ions are stable with respect to being further oxidized? Well, hydrogen's not going to be oxidized any further. Can you oxidize hydrogen plus? How many electrons does it have? Yeah. That's why you don't see H2 plus ever. It's got 1 proton. It's got 1 electron. You take that electron away, you're out of electrons. Make sense?
If it has 2 protons, isn't that technically helium?
Yeah, it's helium.
Irradiated helium.
Yeah. So essentially, obviously, hydrogen's going to be okay. You don't have to worry about it being oxidized. Zinc, 2 plus, is already oxidized. In order for it to be oxidized, it's going to have a reduction potential that is going to be it's going to have a reduction potential that's greater than 1.23 volts.
So the only 2 ions here that can be oxidized are bromide and manganese 2 plus?
Well, the manganese 2 plus, yes, and the bromide.
Because those are the only ones on the right side, which are the only reduced.
Yeah, we're looking at the reduced form exactly.
Okay.
So we're looking at the manganese 2 plus and the bromide exactly. So the manganese 2 plus would not be oxidized because its reduction potential is 1.51 volts. So it would have to have a reduction potential that lies below 1.23 volts. Because here what we're doing is, and let me show you, this is the converse of what we just did with copper. the one that is going to fall here is bromide, which is 1.065 volts. 1.065 volts is so because E naught okay, so that means that once the voltage of 1.065 volts is met, at that point if I have a bromide solution, I may have hydrogen, like sodium bromide, the hydrogen is going to be bubbling off the cathode, and once the voltage reaches 1.065 volts, I'll start to oxidize the bromide at the anode before I'll get to the oxygen. And even if I go beyond 1.065 volts, there's still a bigger driving force for this oxidation. And as long as this has a high concentration, it will continue to be oxidized at the anode. Once I've depleted all that, if I got a voltage greater than 1.23 volts, I'll start to see oxygen bubbling off. But beyond that,
So could you think of it like whichever is close, whichever the element is like closer to?
well, it depends on, we have to be concerned whether we're talking about the reduced form or the oxidized form. The reduced form is the one that's going to be oxidized. The oxidized form is the one that's going to be reduced.
Yeah.
And the party of the first part, the party of the second part, and all that. Okay? It's the language here that's the real it takes some getting used to. You've got to slow down. And so, in this situation, which is a complementary one to the one we had observed when we were talking about things being oxidized, or things being reduced, when we had this voltage, this will be oxidized when I have this voltage. So bromide is the only ion that I see in that field that satisfies that. Make sense? Because you've got to understand, this is my external power supply providing this. And so, yes, bromide would be the only one, so oxygen would be produced for all the others. So that means everything but bromide, and that's it. So this answer for part E is H plus zinc Okay, that answers part E. That question, like I say, is going to be absorbed, and there will be some questions from that on the test. But what you want to be able to do is the derivation up front. Please study this, understand this, take your time with this, but I'm not going to take a lot of the test time on this. Okay? So that should ease your any apprehension that may exist. Because this does tend to be a bit scary on first blush. In fact, even on second or third pass, it still takes a little while for this to set, okay?